So it's talking about the data points in that one, right? It says, oh, where's it at? What's the minimum possible number of miles traveled by an automobile included in the histogram? So in the histogram, are there any automobiles that had 0 miles?
No.
No, it's got to start at that lower class limit, right?
Okay.
Cool.
Even though they say what's possible?
From an automobile included in the histogram.
Okay.
So you got to go based on what you can see in the picture. Yeah. I don't see anybody around 0.
Okay. The same question. What could cause that gap? I mean,
And we talked about that before. Who remembers what could cause a gap when you're looking at miles driven for automobiles? You've got regular everyday people driving to work and whatever, and then you got taxi cab drivers. That's one possible explanation. That's, and then for New York City, that's a pretty good.
But
Okay.
I wasn't sure exactly what sense it made. But it didn't make no sense to me.
Why not?
Because, I mean, could it be a possibility that, I don't know. I don't know what the
So you
gap
can come up with
would
something
be.
else, but taxi cab drivers, do you think they drive more than the normal person?
Yes.
Obviously. So that would explain the gap, possibly. If they had some taxi cab drivers, they're going to drive quite a bit more than the normal person because they're driving the whole day through.
Well, what I put
Yeah.
it is that the normal, usually the normal amount of miles a person drives under normal circumstances is 12,000 miles.
No, you don't have to get all that. To
According
explain the
to-
gap, you say there are regular everyday people included and there are taxi cab drivers included.
Okay.
That explains the gap. Sort of like if you had a gap in heights. There are students included, little kindergartners, and there are their teachers included. That would explain a gap in heights, yeah. Okay. Last time we rushed through, and that's fine. I just want to get it all out there so we can come back at it, having seen it once. The idea of standard deviation?
That's 3.3, right? 3.3.
And I can't stress enough how important this idea is. I know on the concept outline that's online, I say chapter 6 is the most important chapter, and it is. But everything it does is based on this idea of standard deviation. So today we're going to talk. We're going to do another problem. We're going to try to talk a little bit about the concept itself and how you can use it, and how it can be used in everyday life.
Is that 3.3?
Second.
Is that 3.3?
3, yes. Cool. So last time we got this formula for standard deviation. And this is actually I can't remember which letter I used last time, but this is the population standard deviation. I try to make that point. What letter in here is new to us sort of here? I mean, what letter in there is... Yeah, the little mu dude, right? You pronounce that as mu. You know, I was thinking of it as a French cow. So that's a Greek letter mu, and that means the what of the what? I love it. So mu is the population mean, whereas x bar is the sample mean. I love it. So our letters, sample, Greek letters, population. The symbol for standard deviation of a population is, of course, another Greek letter, because it's a population. It's the symbol lowercase sigma. Another S, right? Standard deviation. It's like that. Here's how you make it. Start in the middle, go around and out. Wow. I can make them skinny, I can make them fat. Just make them like that. It is not the letter R. Cool. Maybe. So I'm going to get some neat stuff there. Now, the only difference between this standard deviation and the one for samples, because this is a population standard deviation, right? That's the population standard deviation. And a real quick example of this again. If I told you the average in for this year on quiz 1, and this is true, it was about an 82.5, and the standard deviation was about 10. And this is true. I always calculate this thing so I can tell. And last year, let's say the average was an 82, but the standard deviation was only 5. What would that mean? Just telling you those two pieces of information. This year, it's an 82 average, and a standard deviation of 10, let's say last year was 82, but a standard deviation of 5. What would that mean?
This year's more spread out.
I like it. This year's more spread out. Last year, there were fewer extremes. They were more tightly coiled around 82, right? So do you see how much you'll get to a point where you can maybe even visualize the data set just by me telling you two numbers, the mean and the standard deviation. Where's the middle, and how far does it get away from that middle on average? Those are two crazy important numbers. Very quick summary of my data set. Don't tell me all 1,000 frickin' numbers. Tell me the mean and the standard deviation. That'll tell me almost everything I need to know, right? So the only difference between this and the sample standard deviation, well, one thing is, of course, the letter's different. For sample standard deviation, it's our letter, so it's just the letter S. Another little difference is I won't have a mu in there, right? I'll have an X bar. But you see how that's really not a different formula so far? All my x's minus the mean. All my x's minus the mean. Not a different formula. How are we doing? Divided by, here's where the big difference comes in. And let me try to explain it before I write it up there. Let's say the average age in here was like 23. Okay? And the standard deviation is, I don't know, 8. If I take a subgroup of you guys, if I take a random sample of you guys, more than likely it's either going to be above that mean or below that mean. You guys with me? It's not going to be exactly that mean. So if I take a random sample of people and their average is higher, won't all their individual averages be closer to that average than it would be to the real average? Let me say this again. So there's a real average grade in here. Let me try to make this visual. There's a real average grade in here. There it is, right? If I take a sample of people and I find their average age and say I just happen to pick older people, just randomly. And of course, it's got to be older, younger, most likely. Won't all those data points be closer to this mean than it would be to the real mean? So that's what we call a sample kind of follows its mean. They kind of cluster around their mean. So I have to adjust. If I have a sample, I have to adjust it a little bit. Is it going to be bigger or smaller then? If all these guys are closer to their mean, is that standard deviation going to be bigger or smaller than if I compared it to the real mean? Smaller. So here I'm dividing by n. What do I divide by to make something bigger? Because this is going to be too small. If I just put an n down there, that's too small. We just talked about that. That's too small. What do I do to the bottom of something to make it overall bigger? And make the bottom smaller. Because, for example, what's 6 divided by 3?
2.
What's 6 divided by 2?
3.
Okay, I made the bottom smaller, made the answer bigger, right?
Right.
So if I make the bottom a little bit smaller, right? And this is what I do. I desperately try to get you to understand, at least to a point, why the formulas are the way they are. I don't want you just to, there's the formula, there it is. Yeah.
So, I'm just confused because looking at the symbol table in the front of the book, the little n says the number of values in a sample, but I thought we were dealing with the population.
I keep forgetting about. Officially, this book says you should use a big ass n there,
Right.
and that's just silly. If my sample is the whole population, I mean, I shouldn't necessarily use a different symbol. The book
So you
says a
can use
giant
the
n
sample.
is a population. That's really not necessary. And in fact, I was never taught that, so I kind of fall back on this. N is the number of things I'm looking at. If it's a population, it's the number of my population. It doesn't require a different symbol. So I disagree with the book there.
Okay.
Yeah. But in the book, they have a big N here. But you guys understand? They're saying, oh, that's a population. Ooh, it's big. But, it's just the number of things I'm looking at. Yeah.
In my notes, I know before you were talking about the same formula for standard deviation of population only with the square root.
Yeah. Oh, sorry. Square root. Thank you. Because I have to go back now and say, before you take that square root, there is a name for that before you do that, right? So why do we have to take the square root there?
Everything has to be these done.
And why did we have to square this stuff there?
Has to be
To make the data, smoother than it would be for absolute value, but why did it have to have these things come out positive? Otherwise, they would all add to 0. So this is still the average distance Right? Because how do you find an average? Sum them up and divide by how many there are? The average distance from the mean. That's what that represents. When I square, but I square rooted it, so it's still the average distance from the mean. And that should just make sense. That would be how spread out the data is. On average, how far do they get away from the middle? Well, that's going to be the spread of the data. If they don't get very far away, it's not very spread out. Does that make sense? If I have a data set whose data values, here's the mean, and all the data values, they don't get very far away from that. That should not be, that's not spread out very much. The standard deviation should be kind of smaller than normal. Whereas if I have a data set and the data points are like really spread out, right? That standard deviation should be a lot bigger. So what's the main difference between these two? These data points don't get far away from their average. These do. So the formula that I want to describe how spread out things are better have that freaking distance from the mean in there. And it does. There it is. The distance from the mean is right there. On average, how far do my data points get away from the mean? That's what this guy figures out. That's why we use that to tell us the spread. Okay. So I want to try to do a problem with you. In fact, let's see. Well, let's make it nothing too evil here. Let's find standard deviation for this sample. That's fine. So I'm telling you it's a sample. And if it doesn't say, remember, you always default to thinking it's a sample. They have to be very specific if it's a population. We're not used to having entire populations to work with. Remember, so the first thing I do here is, and here's the formula I'm using here, right? The thing I told you, if you take the sum symbol and cover it, that's what you need to create. That's the column of stuff that you need. So what do I need to do maybe first?
You need to square root on it. What the?
Oh yeah, square root. So I first need to figure out the difference from the mean. How far away does each data point get from the mean? That's what I need to figure out first. So actually, before I can even do that, I need to figure out the mean. I love it. So let's see. Take a quick second here and figure out what the average of these are. I almost made it something nice. Well, that's not too bad. 7.2. Cool. You guys with me? So you can add them up, divide by 5. So you get, and the average here is 7.2. So fill this column out. Put the numbers there that are supposed to go there for that column there. All right, not too bad, right? So this will be
Mine are
Negative 5.2.
good.
Negative 2.2.
2.2, I like it.
Negative 1.2.
Cool.
3.8. 4.8.
Okay, cool. Is that cool? Just subtracting? Yes, ma'am.
I'm kind of confused. Like the product side of the
Yeah, so what's this first thing say? If x is 2, what's x minus x bar? It'll be 2 minus 7.2. And that's where the negative 5.2 comes from. The next column over should be, what should I do next? Square. Okay.
27.04.
So you get 27.04?
4.84.
4.84? 4.84?
That's 1.44. 14.44 and 23.04.
23.04. Okay, cool. How are we doing so far? So if you cover that summation symbol, you can see what column you have to make so that then you can add them up. I can't plug anything directly into these spots here. This whole thing is the sum of these. Okay, now I can sum them up and put that number right there. The whole thing is that number. So if I add these up, I forgot which one I haven't done yet.
70.8.
Sounds about right. 70.8. Okay. And yes, chapter 3, I need to see this.
Okay, I don't understand how you got the second part of it.
Second part.
Yeah, x minus whatever, x bar.
Okay, what's the x bar for this
Yeah,
case?
I've got that one.
Cool.
That one.
So what's the x
second.
here in the first column? 2.
2, okay.
So what's 2 minus 7.2?
Yeah, yeah, I've got that
Okay,
part.
cool.
It's
So
the
this
next-
part.
Yes.
Okay, so then you just take what you just did
Mhm.
and square it. So now in the
Okay,
calculator you can either
5.2.
multiply by itself or
Gotcha.
there's a square button. And you get these guys. Add these guys up, you get 70.8. In the formula that's going to go right up here. And what's n minus 1?
4.
Beautiful, because there's 5 things, so n minus 1 is 4. Cool.
How did you get 4?
Say again?
How did you get the n?
Oh, I'm sorry. N minus 1, so there's 5 things, so n is 5. So 5 minus 1.
Number of x's.
Yeah, n is always the number of my data set that I'm looking at. So there's 5 numbers in there, minus 1 is 4. So you guys said 17 point.
7.
I remember if I said this yet. You have to go at least 3 decimal places out here, right? 17 point.
6, 9. 6, 9 is only.
69
Only.
only. Maybe I should do this.
It's just 17.7.
Yeah, that's all.
17.69.
It's not square rooted.
It only goes to 2 decimal.
But it's rooted.
Oh, well, you square rooted though.
It's not.
Have you square rooted it yet?
Not yet.
It's 4.20.
Oh, okay, cool. So that's the middle step. So what do you get at the end? 4 point.
207.
Beautiful. There you go. So go out at least 3 places. That's the standard deviation. So let me show you what you can do for yourself if I give you a longer list of data. I'm not going to give you a crazy long list of data, but you can see how this will take a little time to create the whole thing by hand. So let me show you how to do it in the lists on the calculator. That makes it a lot easier, a lot quicker to do all this stuff. And then I'll show you the ultimate shortcut, which you can't use until we're out of chapter 3. You can check your answers with it, but you can't do your answers with it. It's going to be an interesting video. Shoot. Okay. Sweet. Alright guys, so in this room it's really strange, but that's alright, we'll figure it out. So, you probably have stuff in your lists, so I would clear out, you actually need to clear out the first, oh crap, that's a long ways. Go the other way, yeah. Go up to list 1, hit clear, enter. You might have to go to L2, clear, enter, L3, clear, enter. Clear out the first 3 lists, right? Let's put our data in here. 2, 5, 6, 11, 12. And I've got these steps on the calculator Bible also. If you go and highlight L2, so see where I am now? Is everybody with me? Put the data in there. Go over to L2. Now hit the up arrow, highlight L2. It says L2 equals something. Well, if I make L2 equal to, where are my x's up there? Okay, so if I make L2 equal to L1 minus 7.2, it's going to give me all this. So make L2, where's my L1? It's right above the 1 button. So if I hit go up, highlight L2, say L2 equals second 1, L1 minus the mean, 7.2. Enter. Pop. So you can imagine if I give you like 15, that's a lifesaver, right? I'm going to need you to copy that down onto your test, but at least you don't have to do every single one. Minus this, minus this, minus this. I hate you, Mr. Wahai. Yeah, sure. All right, so everybody got their data in there? If you try to put it in the first column, it'll say, what the hell? Go to, oops, I tried to put it into a spot. That's no good. I got to tell it the whole list. I want all of list 2 to be my x's, which are in L1, minus the mean, 7.2 in this case. Cool, and you should get the numbers we got here. Now what do you want L3 to be? The square of what? L2. I love it. So go over to L3. Say it's shift or second 2. I want it to L3 to be L2 squared. Bam. And I get these numbers.
I just squared.
Oh, there's a little square button right here. Diagonal from your 7. Next to your comma button. Sitting on the log. Right there. Or you can say to the second power using your to the button. Okay. All right. Yeah.
If we write all this data down and then just use the standard deviation button, can we do that instead of just writing the formula?
Hell no, because I'm about to show it to you. And like I just said, in chapter 3, you got to show me the work. After chapter 3, we're going to be going straight to the standard deviation thing and taking it from there, because we got other stuff to do after that. Chapter 3 is only that. We're going to focus on that. Yeah.
My thing keeps saying error and quit, like it's not letting me go to the next L2. I put L2 minus 74. Give me come after.
No, you have to go up to L2. Now it's L1 minus 7.2. Alright guys, so the last thing I want to show you, here's the, now from here you can just add those up. And you don't have to know this, you don't have to remember this, because you can just add those up. That's easy enough once you write them down. But if you wanted to, you can go, see where it says list above stat? One second, stat, math. Oh, the one thing I forgot though was, let me see. There's a sum button. Now see how I'm still in the freaking list though? So you actually want to get out of your list first. But if you go to second stat math, you can actually tell it to sum up. Number 5 is sum. You can tell it to sum up the stuff in L3. And I should get to 72 or 70.8. Right, there it is. So again, that's in. First get out of your list, so you're not trying to put the sum into a spot on your list. Get out of the list. You don't have to do that. You can just put them down and add the damn things up in your calculator. Not a big deal, right? The shortcut, the ultimate shortcut. If you go to stat edit, let's just look. There's our data right there in list 1, right? If you go to stat calc, that's where I'm able to calculate things based on the data that I put in. So go to hit the over arrow to calc. How many variables do I have up here?
One variable.
One variable. I love it. I've done stuff with it, but there's only one variable, x. I don't see any y. I don't see any z. Right? So I want to do one variable statistics. So let me get in there again. Go to stat, hit over to calc. And again, this is all in your calculator Bible. Number 1 is one variable
How do
statistics.
you get to call?
Oh, just hit the over arrow from hit stat, hit over to calc. And then number 1. Enter. It defaults to list 1. So if your data is in list 2 that you want, you have to tell it list 2. If you just hit enter right now, it's going to tell you all about list 1. It's going to tell you every damn thing about list 1. Do you notice interesting things? What's the first thing it tells you?
X bar.
The mean. And then it tells you the sum of them. It tells you the sum of the x squares. It tells you the standard deviation, which we got 4.207, right? Kick ass. What's this one?
Population.
Why does it give me both? Because it doesn't know. You're just putting numbers into it. It's like, I don't know what the hell. If it's standard deviation, you take the right one. I don't know which one it is. You as the human, you got to do this for me. And if you keep going down, look at all this other stuff it gives you. The only thing we really know here right now is right here, the median, and the mean, and the min and the max. So it actually does tell you the median. That is very good to know. So this is why I must see work. You can always check yourself for this, but I must see the work getting you there. Okay, so next time I'll have the quizzes graded. We'll finish out chapter 3, and I'll have the practice test. Next Tuesday will be just review. I'll have an answer key for the practice test. All kinds of good stuff. All right.
We haven't done 3.4 yet, right?
Say again?
We haven't